Imagine walking into a structure built nearly 9 centuries ago, only to find stone surfaces so impeccably smooth and symmetrical they appear manufactured. There were no electrical grids in the 12th century, no steel lathes, no computer numerical control machines. Yet, standing in this room are rows of solid stone pillars with circular profiles that resemble the output of a modern industrial plant. The existence of these cylindrical columns requires a re-examination of medieval engineering capabilities. This is the Hoysaleswara Temple, located in Halebidu, Karnataka. It was constructed during the height of the Hoysala Empire in the 12th century. While most visitors see a religious monument, engineers see a production mystery, one defined by extreme manufacturing precision. Experts refer to these structures as lathe-turned pillars. To achieve this shape and hard material, the object typically must rotate continuously against a fixed cutting tool. This animated diagram shows how concentric geometric circles align with the stone's profile. There is no significant wobble or uneven wear. Standard hammer and chisel strikes along struggle to produce this level of seamless 360-degree perfection. Moving from the massive columns inside, the investigation shifts to the exterior walls, where the scale of the work becomes microscopic. The figures carved into this facade feature free-hanging jewelry, layered garments, and ornate patterns smaller than a human fingernail. Applying heavy force to carve such immensely fine details into hard rock usually causes the entire stone to instantly fracture. If you were looking at these razor-thin details without knowing their history, would you guess they were nearly 1,000 years old? Let us know in the comments. The builders utilized a specific geological property of metamorphic rock. They sourced chloritic schist, commonly known as soapstone. When freshly quarried, soapstone is soft enough to allow for microscopic carving. Over centuries of exposure to the air, that surface oxidizes and hardens into a durable shell. While the softness of soapstone explains the intricate statues, it does not explain how multi-ton blocks were shaped into perfect circles. This mechanical schematic shows the leading engineering theory. 12th century craftsmen used human-powered rotational machines. A raw block of stone was mounted onto a central axis, with teams of workers using ropes to provide kinetic energy. Once the block reached a consistent velocity, stationary cutting tools were pressed against the spinning rock. As layers were stripped away, the process naturally generated symmetrical circles. Executing this required physical synchronization. Maintaining an even spin on thousands of pounds of rock demanded strength combined with precise mathematical measurement. The Hoysala craftsmen developed machines powered by human kinetics rather than electricity. When mechanical lathe turning was combined with master-level soapstone detailing, the results reached a peak of medieval craftsmanship. These seated deities beneath hyper-detailed canopies showcase a marriage of structural geometry and artistic expression. The logical consistency of these methods, from material selection to mechanical rotation, provides a practical explanation for the site that aligns with the era's known geology and physics. The complexity points toward multi-generational patience and a rigorous understanding of the stone's properties. This 12th century site suggests that advanced manufacturing precision was achievable long before the Industrial Revolution. The awe of Hoysaleswara resides in the capability of the human mind to innovate within the constraints of its own era. Which leaves us with a lingering, profound question. Just how much ancient human knowledge have we truly underestimated? If you enjoyed this architectural mystery, hit the like button and subscribe to Untold Indian Stories. Every week, we explore forgotten history, unsolved ancient mysteries, and unbelievable true engineering marvels from India and around the world. Share this with those who love history and mysteries. Until next time, keep questioning the impossible.